All right, stats. Welcome to a video over the chapters 1 and 2 essential problems packet, or the problems packet. You guys know what it's called. Anyway, I told you that would make you, like a better video. You wouldn't be looking at a video where I just like point at stuff. But this first chapter is very, very easy, and it's less of calculations, as we'll see them soon. So I'm going to make a video like you're used to in the years past. This is in that packet. This is page 3. All right. Again, this is the practice problems packet for chapters 1 and 2. Never on Sunday. Births are not, as you might think, evenly distributed across the days of the week. We'll talk about this when we talk about the chi-square testing. One of the last things we do this week, or this year, all right, to see, is there an equal chance of having a baby on any of the days of the week? Here are the average number of babies born on each day of the week in 2005. Okay, so we can see Saturday and Sunday, less babies being born. You can think about why there might be fewer ones. A lot of babies are being born now to C-section. You can schedule that out. Might want to have it done on a Tuesday so you can be home on the weekend type of thing. I don't know, many different things. If you have a natural birth, that can be sometimes hard to tell. Anyway, so what I've done is I've made a bar graph. 1.5, here's a bar graph. So first off, we go from basically go almost to 14,000. I labeled every 2,000. Sunday was at 7.3 thousand. Then you guys see the numbers. Something like that. Tuesday through Thursday are only separated by like 150, so they're very close. And Friday is so close to that as well. Saturday goes down. That is a bar graph. Sometimes the bars are right next to each other. I like to make my bars like that. All right, that's how you make a bar graph. I don't know if you have any in your homework, actually. So then turning over in that same packet, page 4. Here are the first lines of a professor's data set at the end of a stats course. Their major, their points, their grade. I started writing, they didn't ask this, but your major is categorical. Points, score, quantitative. They're the names of the students. Then on page 5, the question asks, the individuals in these data are the students. That's what we're looking at, who are the individuals, the students. So to display the grades, A, B, C, D, or F in a course, it would be correct to use what? So in that definitions packet, which you guys have to look at on your own, a pie chart, you need every single outcome possible. Well, A through F is every single outcome. And we can also do a bar graph on those. So we could use either a pie chart or a bar graph. Okay, 115, a study of recent college graduates records their sex and total college debt in dollars. Okay, so sex is a categorical variable, puts you in a category, and college debt is quantitative. Political party has zip codes of past donors. Zip code is categorical. Okay, I can't do any meaningful math with that. Just put you in a category. 90210 Beverly Hills, I believe. This is in New York. And then that's relatively close. That's relatively close. You guys, 62056. All right. Let's see. We don't have that figure. But here are the amounts of money, cents, in coins carried by 10 students in a stats class. To make a stem plot of this data, you would use the stems. Okay, so we're talking about cents here. We go to like 97. So the stems would be that tens digit. Okay, the leaves would be the ones digit. So I have 3 zeros. I would go 0, and because it's just 0, it would be like 0, 0. There's 3 zeros, so 0 for the tens and 0 for the units as well, all right? Which we don't really mess with 0 a lot. 23 would be 2 tens, 3 ones. 35 would be 3 tens, and then 5 ones. And then 50, 5, 0. 6, that's for 60, 5, 76, 87, 9 tens, 7 ones. That's how we would make it, okay? Population of the United States is aging, though less rapidly than in other developed countries. Here's a stem plot of the percents of residents 65 or older in the 50 states and DC. The stems are whole percents and leaves are tenths of a percent. So that means 6.8 there is 6.8%. There's 51 total. What I did is I found the 26th one, which would be the true middle. 12.8% is the median. 16.8% is the high number. Now, they mention on the next question an outlier. So notice we have some pretty good symmetry here. Like right here we have a lot. So you got to ask yourself, from that middle, what's further off? 16.8 or 168 here, or the 68? So actually 6.8 is further away. So we would count the 6.8% as probably the outlier. Okay, the outlier is Alaska, 6.8%. That's what I would do without any investigation. I mean, we could find the mean and the standard deviation, and then we could actually show that it is probably that 6.8. Ignoring the outlier, the shape of the distribution. Okay, if we ignore the outlier, bye-bye outlier, it's going to be roughly symmetric. Here's your middle. Those can somewhat cancel. Those somewhat cancel. Where am I at? I mean, this is kind of your middle. Those would cancel. Those kind of cancel. Those, I mean, it's going to be roughly symmetric there, all right? There is no skewness. Now, we'll talk about skewness again. That is in your essential definitions packet. I gave you some sweet examples on skewness. You need to write that. Look at real estate. Oh, the center is 12.8. That we can find that. It's the one exactly in the middle. You look at real estate ads for houses in Naples, Florida. There are many homes in the $200,000 to $500,000 price. This book was made 10 years ago, so they're more expensive. The few houses on the water, though, are up to $15 million. Holy cow, that's way to the right. So you're going to have some decent symmetry, and then boom, it's way over here. So if something pulls the average up, that means it's being skewed to the right. Definitely skewed to the right. All right, 123 here, medical students. So the individuals described are medical school students. And then medical school, that's a categorical variable. Your gender there, categorical. Your age is quantitative. Your score is quantitative. And then your specialty is categorical. On 124 here, they want to know which are categorical, which are quantitative. Type of wood, categorical. Type of repellent, put it in a category. Paint thickness, you can find an average difference, quantitative. Paint color, categorical. And weathering time in months, categorical. Not categorical, quantitative. Those are all right. If I said something, those are all correct. All right. All right. Going to keep going. Again, just some easy definitions. Then we get into the number crunching in a few days, and that's what I'm all about. Add them up, you get 95%, so the other category would be 5%. And we're not going to make a graph. Just add them up, subtract. Now we can make a bar graph. If we wanted to, we could do a pie chart. Okay, you need the other category, or in this case, I guess the other category would be under 12, and that's 5%. So in order to make a pie chart, you need all categories, which in this case would be people under the age of 12. All right, then let's go to 140 here. Let's talk about relative frequency. So if you're looking at this, this is marijuana use per year. So you might be like, oh, look, the people that never smoke marijuana, they cause more accidents, and the people that smoke a lot cause less than them. Well, it's all about relative frequency, okay? Relative frequency, so this is the frequency. 59 accidents were caused by people that never smoke. People that are 1 to 10 times smoking, 36 were caused to them. These numbers, 59, 36, 15, and 50 are the frequencies. The relative frequency, though, is what's more important. There were 452 drivers that never smoked marijuana. 59 caused an accident. So the relative frequency is 59 divided by 452, 0.131. For a frequency, we're going to keep it between 0 and 1 like a proper proportion is. not a percent. We use percents for pie charts. Basically, 13.1% of people that never smoke marijuana in a given year cause an accident. Then, as the smoking goes up, so do the accidents caused. 36 divided by 229 is that. 15 divided by 70 is that. And then, holy cow, those of them that used at least once a week, 32.1%. Again, we write a frequency as a proportion, a number between 0 and 1. I have another relative frequency one coming for you, and on Wednesday and Thursday, that's what we're going to spend some time in class doing. In fact, on page 9 here, number 23, favorite day of the week to eat out. Monday through Sunday, there are 40 responses there, and I have added them up. We're going to start with 124 in class, or number 24 in class on Wednesday and Thursday. So page 9, number 23, there's 40 total. So Monday, 2 people were like, that's my favorite time to eat out. So the frequency is 2. The relative frequency is 050. Now we're going to make a pie chart as well for this. All right. On Tuesday, there were 5 choices for Tuesday. So that relative frequency is 0.125. Wednesday, 6, relative frequency 0.150. Thursday, 2, relative frequency 0.050. Friday, 14, relative frequency 0.350. That's the work you're going to show for me later, especially on your homework. Saturday, 8 out of 40, relative frequency 0.200. Sunday, 3 out of 40, 0.075. So this is the relative frequency. This right here. Okay, now for the pie chart, we're going to make, and when we put things in a pie chart, it's going to be percents. Percents rounded to the nearest 1/10 of a percent. Yeah, 1/10 of a percent. Okay, so the order doesn't really matter here. I'm going to go in a different order. What I want you guys to be smart on, so if I look at 35 and 15, I know that that is half. That adds to 50%, which is half of my pie or my circle. So I'm going to put, what I did is I put a dot in the middle, and I can draw a line down. That's half of it. And Friday represents about 1/3. So 35% is Friday. That means this little slice, 15% would be Wednesday. Next came Saturday at 20%, and it's just a little bit under 1/4. All right, then, roughly half of that is Tuesday. And then with this little bit I had left, I made Sunday a little bit bigger, and I tried to make Monday and Thursday, they're both 5%, very small representative, okay? The only way you miss this is, A, your percents are wrong, or if you make Friday look like it's exactly half or more than half, okay? If this looks good enough, I'm not going to stress too much about that. And I'm thinking, so go to page 12 here. Let's end this video here quick. Page 12. So number 7, this is what skewed to the right means. Okay, so it's being dragged. Its tail is going to the right. The tail is going to the right by those numbers that, so it'd be false. It's not skewed to the left. It is skewed to the right. You have some high performers there. This is roughly symmetric. Okay, that is definitely roughly symmetric on 8. Then I believe that is, nope. I got another one on page 14. Again, we'll practice some more of these. On page 14, let's take a look at 22. All right, so what is the original numbers in the data set? This was in your essential definitions packet as well. So 240, 244, 247, I went in this order. 252, 252, 253, 259, 259, 263, 264, 265. The first 268. And I went over here, the next 268, 269, 270, 271, 271, so forth. Those are all the numbers. Okay. And I believe that is a good one to end on. We will finish this Wednesday and Thursday in class. And I'll give you some more hints for that, some practice problems. We'll practice those on Fridays, how do you get some questions that look like your homework set. And then chapter 1 will be done. All right, it's a quick chapter. Then we get into the sweet, sweet calculations. This is Yak Math Videos signing out.